Hello everyone. In this video, we will be discussing about Module 3 in non-traditional machining process. As we know that already in Module 1, Module 2, Module 4 and Module 5, we have discussed the different types of non-traditional machining process. So and even the major purpose, what is the need and the applications, all those things in detail we have discussed about all the non-traditional machining process. Say for example, ultrasonic machining process, water jet machining process, abrasive jet machining process, and even plasma arc machining like laser beam, like that we have discussed different types of machining process. And what is left out in our syllabus is that is module 3, where we'll be discussing about electrochemical machining process and chemical machining process. So even basically these two machining process are the metal removal process only, but it has its own limitations in the sense like for which applications or for which material it is recommended. So that we'll be discussing here. So first of all, what do you mean by electrochemical machining process? As I discussed, so it is a metal removal process and which is based on the principle of reverse electroplating. So when I speak about the reverse electroplating, we should have little chemistry knowledge, because we should be knowing what do you mean by electroplating, what is cathode, what is anode. So all those things we should be aware. So then only it is possible to understand properly, and even in case if you are planning for any setup on the working means, we should be aware, okay, what is the anodic material recommended, or what do you mean by cathode material, all those things will be aware. Okay, so basically in this process particles travel from the anodic materials. So here anodic material is nothing but the workpiece whatever I am keeping towards the cathodic material. Cathodic material is nothing but the tool. We can in other non-traditional machining process we called it as an electrode, but here we will be calling it as a machining tool. So a current of electrolyte fluid carries away the depleted material before it has a chance to reach the machining tool. So the cavity produces the female mating image of the tool shape. So basically in general we can call electromachining is a machining process in which electrochemical process is used to remove materials from the workpiece. So it is a combination of both electrical energy and chemical energy, and even in this process workpiece is taken as anode as we discussed, and tool, that is a machine tool, which is taken as the cathode. So the two electrodes, the workpiece and the tool, is immersed in an electrolyte. So electrolyte is something which will conduct the electricity, and even it will try to pass the electricity. So here what kind of electrode here I am using is sodium chloride I will be using, and when the voltage is applied across the two electrodes, the material removal from the workpiece starts. So and based on the amount of voltage I am applying in terms of amps, like whatever I am applying, like and even the kind of workpiece I am using, so based on that I will be supplying required amount of the voltage, and the workpiece and the tool is placed very close to each other without touching. So in electrochemical machining process, the material removal takes place at atomic level so that it produces a mirror finish surface. So the major drawback, or even we can call it as the difficulties what we generally face in the conventional machining processes, the surface finish and even the cutting of some hard materials. So anyway, in non-traditional machining process there are many machining process which is widely recommended for machining difficult to cut machines or metals, but still the surface finish it's quite a challenging part in the conventional machining process, but which we can overcome by using many non-traditional machining process. Similarly, like other machining process, even in the electrochemical machining process, where the surface finish is very good, and even this process is used to machine only conductive materials. So when we see the chemistry, that is that list of metals, and even we have non-metals too, but in this particular electrochemical machining process, where it is applicable only for the materials which conduct electricity, then only it is possible to remove the metal. So it has its it is a major what is that limitation of this electrochemical machining process, we can call it. So what is the principle of electrochemical machining process? So electrochemical machining, it is based on Faraday's law of electrolysis. So what is Faraday's law? So the Faraday's law states that the mass of a metal altered by the electrode is proportional to the quantity of the electrical charges transferred to that electrode. And you can able to see this. So till now we were talking about this workpiece and machining tool. You can able to see this is the workpiece, which is basically anode, and this is the tool, or we can call it as the machine tool, which is a cathode. So that is positive and the negative charge is connected. You can able to see this, there is an electrode. So here what is the electrode we are using? Sodium chloride is the electrode we are using, and you can able to see there is a passage in the tool holder, and through this passage only the electrolyte will be supplied to the workpiece, and it is immersed in such a way that it will spread uniformly across all the workpiece. So whenever an voltage is supplied through the to the machining tool, the current will be passed immediately in the presence of electrolyte, and in turn the metal removal will takes place. And all these arrow marks show like the direction of the movements of the current and even removal of the metal. And the major components we can able to see is the tool, where is the tool holder in the feed mechanism, and this is an electrolyte supply, and there is an insulation provided, since even though it is fully automatic, manual operation is also required for the maintenance and other thing, so that to make sure that the current like electrolyte any leakage or any problems, so that can be prevented by the proper insulation provision. And similar to the electrical discharge machining, here also the workpiece hardness is not a factor. Because electrochemical machining process is suitable for any machining which is difficult to cut, and difficult shapes can be made by this process on materials regardless of their hardness. And even a schematic representation of the electrochemical machining process is shown in the next slide, where the electrochemical machining tool is positioned very close to the workpiece, and a low voltage and high amperage direct current is passed between the workpiece and the electrode. So some of the shapes made by the electrochemical machining process is shown in the sketch itself that I will show. And talking about the metal removal rate in electrochemical machining process, which is nothing but C into I into H, and unit is centimeter cube per minute, where C is nothing but specific metal removal rate, and example the specific metal removal rate, for example 0.2052 centimeter cube per amp per minute in a minute for a nickel, and I is nothing but current in terms of amps will be supplying, and a small h is nothing but a current efficiency, which is generally 90 to 100%. So the rates at which the metal can be electrochemically removed are in proportion to the current passed through the electrolyte and the elapsed time for that operation. So many factors other than current influence the rate of machining. So these involve electrolyte type, rate of electrolyte flow, and some other process conditions. So I was telling some of the parts which can be made by the electrochemical machining process. Here you can able to see some of the examples. And these are all the different parts or the elements which we usually recommend it for like a many big machine assembly process, and some of the cases where it will be the major part, like even for the minor parts like maybe a screw and fastening purpose also we can use it, but some of the major process it may be like the heart of the major like a machine. Even these parts can be made by using this electrochemical machining process. So electrochemical machining process working is opposite to the electrochemical or galvanic coating or deposition process. So during the electrochemical machining process, the reaction takes place at the electrodes. That is the anode, we call it as a workpiece, and cathode tool, and within the electrode. So let us take an example of your machining low carbon steel, which is mainly composed of the ferrous alloys. So we generally use neutral salt solution of the sodium chloride as the electrolyte to machine ferrous alloys. The ionic dissociation of sodium chloride and water takes place in the electrolyte, which is shown in the below. So we have a chemistry like chemistry equations and even the equipment parts that we can continue in the next video. Thank you.